Good morning, guys. We are still working our way through geometry. We are going to start talking about quadrilaterals. So far, I know it's been a bit of new vocabulary and all of that, but we are going to continue talking about angles. We've talked about triangles a little bit and circles a little bit. So now we're going to talk about quadrilaterals. So specifically, a quadrilateral is just the name of a shape that has four sides and four angles. So as you guys can see to the right, all of these shapes that are up here are examples of quadrilaterals. So a quadrilateral is kind of just the over, kind of the big name for all of these shapes. So shapes, again, like triangles where we talked about the other day, we talked about isosceles and acute, are named on their sides, but also their angles. So quadrilaterals are the same way. So under quadrilateral, I kind of have two branches. I have a quadrilateral being four sides and four angles, and then off of that I'm going to start with the trapezoid. A trapezoid has one set of parallel sides, so the bottom and the top are both parallel. The sides are not parallel because if I continued to draw the line straight, they would eventually intersect. So a trapezoid is kind of by itself as far as being a quadrilateral. So a quadrilateral or a trapezoid is a type of a quadrilateral. So all of these are going to be like that. They all fall under the category of a quadrilateral, but when you are classifying them, you need to be more specific. So then going to the other side, a parallelogram is a shape that has both pairs of opposite sides that are parallel and congruent. So what that means is the opposite sides, meaning this side right here and this side right here, are parallel to one another. Again, if I were to keep drawing a line, they're not going to intersect. And then congruent means that they are equal to one another. We talked about that word yesterday. So then this top and this bottom are also parallel and also congruent. So any shape that has equal sides and are both parallel to one another is also going to be a parallelogram. So breaking parallelogram down, there are three shapes that fall under this category. So I have a rectangle. A rectangle is a parallelogram. It is also a quadrilateral that specifically has four right angles. So it still has the two pairs of opposite sides that are parallel to one another, so the two sides and the top and the bottom, and they're also congruent to one another, so the two side lengths are equal and the top and the bottom are equal. But it also has four right angles, so remember the little box we've been drawing with right triangles, that's the same thing. So if you go back and look at the parallelogram, it doesn't necessarily have a right angle. The sides are not straight. So that's kind of the difference with a rectangle. And then a square. A square has four right angles and four congruent sides. So you guys should know what a square is. It has four sides that are just all the same length, but it also falls under a parallelogram because the two pairs of sides are parallel and they're also equal to one another. In a square's case, all sides are going to be equal, but a square is still a parallelogram and also a quadrilateral if you want to keep moving up the chain. Then you have a rhombus. A rhombus is also a parallelogram. A rhombus has four congruent sides. So notice that it doesn't have four right angles. So the angles on a rhombus are not right angles, but they do have four sides that are going to be equal to one another. So kind of picture a square and you pulled two sides and kind of manipulated it and squished it down. Or think of like a diamond is kind of what a rhombus looks like, except for all four sides are going to be equal to one another. So those are the shapes that we're going to be talking about. Whenever you guys are classifying them, make sure you're not just writing quadrilateral for everything or parallelogram. Be as specific as you can. If it's a square, write square. You don't need to write square, parallelogram, and quadrilateral. If you write square, that tells me that you know that it's a parallelogram and also a quadrilateral. So going to this next slide, you are getting into drawing and classifying, and this should say quadrilaterals, not triangles. I was thinking about triangles. Okay, so looking at this, the first one is asking you to draw a parallelogram that has 4 right angles and 4 congruent sides. So it would be a little easier for you to kind of classify it before you draw it. So going back to the previous slide, a parallelogram that has 4 right angles and 4 congruent sides would be a square. So it has 4 right angles and 4 sides that are the same. If you guys have a ruler at home or something to measure, if not, draw your square as best as you can. Then I'm going to just on one side, but that signifies that it is a right angle. So technically all 4 sides would have that. You guys are going to see that on your homework. So then a quadrilateral with opposite sides that are parallel. So going back to the last slide, I know it's a quadrilateral and it has opposite sides that are parallel. So looking at that, none of these have opposite sides that are parallel. So if you were to just think about drawing 2 parallel side lengths, it doesn't say that all are parallel. It just says one that have opposite sides that are parallel. So the opposite sides that are parallel is going to be a parallelogram. So it doesn't tell me if they have right angles, if they have 4 congruent sides. It just tells me that they have opposite sides that are parallel. So this next shape is just going to be a parallelogram. And I know on this slide I've been drawing them this way, but you can also have one that goes the opposite way. That is still a parallelogram. Then the third one is asking you to draw a quadrilateral with exactly 1 pair of parallel sides. So it only has 1 pair of parallel sides. So going back, it's a quadrilateral, and then the shape that only has 1 set of parallel sides is a trapezoid. So I'm going to draw a trapezoid. So again, you can make this shape kind of your own. It doesn't have to be exact. It can be smaller, it can be bigger, as long as the top and the bottom are parallel and the 2 sides are not parallel. So as far as classifying them, this first one would be a square, the second one would be a parallelogram, and then the third one would be a trapezoid. So looking at this next slide, and I'm going to make this one bigger so you guys can read it. So yesterday we spent the day talking about triangles, and we talked about the degrees of a triangle need to add up to 180 degrees. So a quadrilateral can really be broken down into 2 separate triangles. So if I were to draw a line like across or this way, I would now have 2 triangles that are making up my quadrilateral. You can do it for any of them. You can cut a square diagonally and make it into 2 triangles. So because I know that I can do that with a quadrilateral, I then know the total amount of degrees that are in one. So if I know one triangle is 180 and I know a second triangle is 180, if I add that back together, the total would give me 360. So the angles of a quadrilateral are going to add up to 360 degrees. So this is similar to the circle. The circle added up to 360. A quadrilateral also adds up to 360. So with that being said, this is kind of the same thing that you guys have done from supplementary to complementary when you were adding to 90 to 180. Circles were 360, triangles were 180. So now getting into quadrilaterals, they're going to add up to 360. So you guys can see that I already set up the equation right here. This shape is a trapezoid. It has two sets of parallel sides, the top and the bottom. And then my two sides are not parallel. They would, if I were to continue to draw them, they would intersect. So again, if you're doing this using the formula, I have all of the sides and they're going to equal 360. So I have 85 plus 73 plus 59 plus x is equal to 360. So I'm going to go ahead off to the side and add 85, 73, and 59. So I have 85, 73, and 59. That's a really bad 9. Sorry, guys. So I know 5 plus 3 is 8, and then 8 plus 9 is going to give me 17. So now I have 8 plus 1 is 9, plus 7 is 16, plus 5 is going to give me 217. So if I'm filling this in, this is 217 plus x equals 360. Remember, to get the x by itself, you are going to subtract the 217 by the other side. So remember, you're doing the opposite operation in order to move things in an equation. So I'm going to subtract 217. So now I have x by itself. I can't take 7 from 0, so I have to borrow. 10 minus 7 is 3. Then 5 minus 1 is 4. And then 3 minus 2 is 1. So that missing angle up here is equal to 143 degrees. So you can set it up like that. Your shapes that you see may be a little bit different, but just regardless of what shape it is, whether it's a trapezoid, a parallelogram, just a normal quadrilateral, all of the sides need to add to equal 360. So I'm going to show you guys another example that is in your homework that's kind of a little bit trickier. So looking at this, you can see that there are two x's, but the x's have to equal the same thing. So there will never be a case where you guys get two letters like this and one x is going to equal 8 and one x is going to equal 10. So in the case of, in this shape is a parallelogram. So in this case, remember the definition of a parallelogram was that it had two pairs of opposite sides that were also congruent. So if the sides are equal, that also means that the angles are going to be equal. So because these two are 60, the other two are also going to be equal to one another. So if I'm setting up this equation, what I really have when I do this is x plus 60 plus 60 equals 360. So I know this is a little bit different than what we've done before, but if I have x plus x, I then have 2x. So I'm going to go ahead and add that. And then I have 60 plus 60 is 120. And then I have 360. I'm going to go ahead and move the 120 to the other side. So I'm going to do that by doing the opposite operation and subtracting. So now I have 2x left is equal to 360 minus 120 is 240. So if I have 2x, and if these need to be, both x's need to be the same thing, what I'm really doing is taking 240 and dividing it in half. So the reason I'm also doing that is if I have 2x, remember a number next to a letter means multiplication, and then the opposite of that is division. So I would divide both sides by 2, and then this finally leaves me with x by itself, and 240 divided by 2 is going to give me 120. So both of these angles would be 120. I would add it back up just to check that you're right. That would kind of just be an easy way to think about it. So again, you can even think about this as a breaking it up into a triangle. 60 plus 120 is 180, and then again on this side is 180, and we know that 180 plus 180 does equal 360 degrees. So that's the only other example that's kind of more difficult that's on your homework. I think you have 2 of them that are like that. This one is actually one of the questions that is on your homework. So if you are watching this, you should definitely be getting this right. So if you guys have questions, please reach out to me. I will be more than happy to help you. And I hope you have a great Friday and have a relaxing weekend. Bye, guys.